Hello, everyone. How's it going? How's it going, chat? Welcome. It is January 24th. Tuesday, January 24th, 2022. And we're back with another live coding stream. I hope you all had a great weekend, great Monday and Tuesday to your week. And let's get into it. We got a fun night scheduled for us. We have a lot we're going to look into, so I need to make sure I'm muting all the things I'm listening to. And let me know if you can hear me okay. What's up? We got Chai Time Data Science is on. What's up, Chai? What's up, Siam? I set my alarm early to catch this one. Oh, hopefully you didn't get up way too early. We're just going to take a first look at a Kaggle competition. We got Twitch first. Yes. RB Moth, welcome to the chat. Everyone can hear me okay. You can hear the music. You can hear my voice. That's all that matters. So we're going to get into a Kaggle competition today that was just launched last week. I've downloaded the data and we are going to try to figure out what is going on. Shall we? You guys ready to jump into it? So let's go. Let's go into it. Let me make sure I got my chat here. Got my other info here, and I'm going to move this over, and we're going to learn about what we're going to learn about today. All right, so this new competition was launched on Kaggle. IceCube, Neutrinos in deep ice. Very cool idea, very cool competition where we have some legit measurement data, some sensor data that we're going to be able to use to try to measure the direction of neutrinos. Neutrinos? Am I pronouncing that wrong? I'm sure I'm pronouncing that wrong. I hear music, but you don't hear music? Okay. That's cool. It's on very quietly in the background. First time watching me live. What's up, Grusha? Welcome. Competition looks awesome. Yeah, I agree. It looks pretty cool. Goal of this competition. So we're given, if we just look here on the data tab, we are given 117 gigabytes worth of data. But one thing to keep in mind about this is they're pretty smart here. They've wised up in these competitions and they're starting to provide the data in Parquet format. So even though that we have this data that's 117 gigabytes, when we expand this into memory, this is going to be a pretty large data set. So we got I'd say medium sized data set, not small, not so big that we still can't use it on one machine or on a Kaggle notebook to create some models. But this is pretty exciting. It's a good sized data set, a lot of files, and they've broken it down into batches. But before we get too far into this, hey there, what else? Who's that we got chatting? Who's that we got chatting? Lots of biology stuff going over my head. This isn't even biology. This is like astronomy almost. I don't really quite understand it even. Neutrinos. Neutrinos. That sounds a lot better. Giovanni, thank you. Neutrinos. We're measuring the direction of neutrinos in the ice. I'm looking for Peru. This is my first live video. Yes, Daniel, welcome to the chat. So happy to have you. All right, so what is this massive thing they show here in the top of this? Oh, by the way, 50K in prize money. What's this massive thing that's sitting in the South Pole? And what is this picture of it? We're going to figure this out. We got someone from Brazil. Welcome from Brazil. We got someone from Turkey. Sinan, welcome to the chat. Hope you're doing well. Make sure you guys all chat. You all hit the like button. You do everything. You share this on socials. Let's get this thing trending. Let's get this competition first look trending. Okay, so the goal of this competition is to predict a neutrino particle's direction. You will develop a model based on data from the IceCube detector, which observes the cosmos from deep within South Pole ice. This is confusing. So we're trying to measure these things called neutrinos, which have like no electrical charge to them. They're just, yeah, we're going to learn more about that. Your work could help scientists better understand exploding stars, gamma ray bursts, and cataclysmic phenomena involving black holes, neutron stars, and the fundamental properties of the neutrino itself. Someone from India, what's up, Umar? So one thing I realized when I was doing my little bit of research on this, I'm going to pull this over here. So there's a video speaks 1,000 words, right? So we're going to learn a little bit about this IceCube by watching a video. This is a video I think I watched some of earlier today. Try to make it so you guys can hear it. So I'm going to mute the other music. Let's pause this. Let's try to bring the sound up. And this might make this have a little bit more sense.
An almost undetectable particle with hardly any mass that travels at close to the speed of light has taught us more about the universe than we ever could have expected.
This is why neutrinos are important.
How do you study the universe with a particle so elusive? Using neutrinos to unveil the distant, unseen reaches of the universe requires a colossal detector. So we built.
So they're like flying at the Earth at all times.
In the world, over 5,000 light detectors buried deep in the Antarctic ice.
Okay, so 5,000. I think this is the same thing. Although, yeah, this is a different video than I watched before because this is only a year old. But look, these are all the measuring devices that are underneath the ice in the South Pole. So this thing exists and it's taking measurements, and we're trying to figure out which direction neutrinos are facing because of this device.
The South Pole Neutrino Detector.
Can you guys hear this okay?
Neutrinos appear in our...
Music was muted earlier. Yeah, volume was really low, so maybe only I can hear it.
So when we saw that the showers of light glowing in IceCube, that was one of the most magical moments of my entire life. That was it. We knew we had it.
We're scientists, so we question everything. But if you might have had doubts about any one of those neutrinos that we first detected, together they were crystal clear.
Astrophysical neutrinos exist, and we can now see them with IceCube.
Astrophysical neutrinos exist.
After 2013, we were seeing a few high-energy neutrinos from the cosmos per month. However, these alone would not be
Also
enough
share the
to
video
answer
link
the
in
next
chat.
big
Let's do that.
question. Where do they come from?
Where do neutrinos come from?
First
We're going to
answer in
help solve this,
2017 when IceCube
this
detected
question.
a neutrino from the direction of the constellation Orion. We sent an alert with the coordinates to telescopes all over the world. And together, we traced a path back to a black hole 4 billion light years away.
Okay, so they're able to detect that black hole from the
neutrinos. A dream come true. The result of the tireless, skillful efforts of a team like
This
no
video
other.
doesn't seem to have all the
It has
details
been
that
an
the other
incredible
one did.
journey. We not only built the first high-energy neutrino telescope, we also...
Okay, so we know that finding neutrinos is important. This is the one I watched earlier.
You know, that contributes, but the wind. And even further back, you can see the meal. And as you may have heard...
No, this isn't the one I watched earlier. Where is it? IceCube. Neutrinos. Neutrinos. It was about 8 years old. 2 years. This one. Neutrino. IceCube measuring the unexpected.
Photons coming from the stars, galaxies.
Walls, light doesn't.
All right. Let's get to work.
Guesses are that we are seeing very powerful cosmic accelerators, maybe...
Tell me when you guys get the point.
The South Pole ice itself is the detector.
Audio is desynced.
Between 1.5 and 2.5
Oh, it might be because of delay.
below the surface, groups of
Good morning,
light
Lapta.
sensors are in position to see the light.
All right, so this is how
by
big this
particles
thing
passing
is.
through the
One of the
ice.
things I thought was pretty interesting
Over
was
5,160 of these light sensors have been deployed, instrumenting a volume of 1 square kilometer under the ice.
all right, so a whole kilometer
High-energy
under the
neutrinos
ice
produce a
has
zoo
these
of
sensors in
charged
it.
particles when they interact with the ice. These particles produce an explosion of light, and IceCube captures it in its sensors. What's critical
Don't
in
ask
the
me
design
why they
is
need to
how
do this in
far
the South
light
Pole
travels through the ice.
with ice.
The light sensors have to be spaced according to the absorption length, the average distance light
Oh, I thought
travels
this
in
part
the
was
ice.
cool.
In tap water, light will travel 2 meters. In distilled water, 8 meters. In ice beneath the South Pole, light travels more than 100 meters.
All right,
In some
so
places,
light,
even more than 200 meters.
like this
The
ice
in
is
the
just
South
so
Pole
crystal
is one of the
clear that
clearest
the light
solids
can
that
travel
exists.
much farther
It
through
may
it.
not be possible to build a solid in a laboratory as transparent as this ultra-pure ice.
It's just like the most pure thing you can get. Hi, this is the first time watching your stream. Just curious how much depth you usually go into understand the context, aka how is it relevant to the model? Usually actually not this much, but these videos are pretty cool and interesting. So I think they give us a good idea of what's going on. I'll put this link in the description too. This one is about 8 years old, so I don't know if it's out of date. But it seemed like a good video to get an idea of what was going on. Now I'm going to turn the music back on. So let's turn that volume down. And hopefully it sounds okay to you guys. This is going to be really fun, Umar. So we're trying to detect, using this sensor information of all these different sensors, the direction of the neutrinos. Let's see what the evaluation metric is. The evaluation metric isn't super straightforward. So we're trying to predict the azimuth and the zenith values, which together will go with each with an event ID. So there's a special notebook that details how the scoring metric is computed. It's the mean absolute error of the angular distance between two directions. And I think I saw some examples in the notebooks that will probably explain this a lot better. Is it a tabular data competition? Yeah, it looks like it's sort of tabular, more like signal data. But we shall see. Timeline, start date, prizes, code requirements. Okay, so let's look at some of this code. Definitely uploaded some of these earlier, but there's so much going on, so much exciting stuff in this competition. So we kind of looked at the data here before, but I've also already downloaded the data into my mounted My Disk folder, and I have this Kaggle IceCube data folder. Now we can see here there's a zip file that I could probably delete. It's about 90 gigabytes. But if I do du-sh, this is about 200 gigabytes of data in here. Yeah, so what are we predicting? We're going to get that. We're going to get to that. Before we do that, let's just look at what we have in terms of data. So if I go into, actually, let me exit out of this. So if I activate Kaggle 2, I go into IPython. Let's list what's in this directory. Let's import pandas as PD, and let's just read this Parquet file, which is train metadata. All right. So now if we look at the data frame head, once this is loaded in, it's kind of big. So let's kind of see how big this is. Train metadata is 3.6 gigabytes. So let me see, make sure my my computer's not overloading with memory. No, it's just taking its sweet time to read in this large file. What do you do outside YouTube? I have a full-time job. I'm helping run a Kaggle competition for the NFL right now. But other stuff like that. All right, so the shape of this is 131 million rows. Let's see how many unique event IDs. I think the event IDs should be unique. Zoom, please. How's this going, Imposter Engineer? I'm trying to keep it zoomed out enough that I can still see the memory use here at the bottom. So we're just trying to get some general metrics of what we have here in this data set, but it's large enough that I think we might want to use polars here. We're only allowed to watch if we buy 4K monitors. I hope not. I'm trying to make it screen as big as possible for you guys. Data-wise, which NFL team is the best? No comment. I really wouldn't know. That's a good question, though, Joseph. All right, so we see that the shape of this data frame is the same as the number of unique event IDs. So this metadata has these events. And then we also can see which batch that they all sit in. So there is this metadata. And then there's in the actual train folder all these different batches of data. Look, it goes all the way up to like 660, it looks like. So a lot of data. Each of these is 162 megabytes. And we're going to have to figure out how to work with this. Someone else in this notebook has done a great job of doing some of the basic exploratory stuff. So we may skip over a little bit this and just learn from them. There's also this sensor geometry, which shows us there's a lot of cool 3D plots in this because of this big, huge thing that sits on the ice or under the ice. We can actually visualize the sensor data that we have. So these are all the different sensors, those little balls of light sensors, I guess, in 3D. So we can see how they kind of sit, and then we can see how our training data, let's see if they show us one. Yeah, this is our training data. And it's basically different values for each of these sensors. So we can kind of see these over here. And the thing is, there's this let's also go into the data set. So probably instead of me just assuming, let's read about this. So there's also this auxiliary, which is a Boolean value. So let's see what an example event looks like. The following image shows a visual representation of the features of an IceCube event in the dataset. The colorful dots represent sensors that logged at least one pulse in the event. The size of the dots corresponds to the total charge of all pulses, while the color indicates the time of the first pulse. The left panel shows only pulses with auxiliary equals false. And the right panel shows with auxiliary equals true. Small gray points indicate the positions of all cube centers. The red arrow shows the true neutrino direction of the event. So we can see that auxiliary, if true, the pulse was not fully digitized, is of lower quality and was more likely to originate from noise. So it looks like this auxiliary is going to be very helpful for filtering out the noisy data sensors, sensor data. If false, then its pulse was contributed to the trigger decision when the pulse was fully digitized. So it's pretty clear in this one that when you use the auxiliary equals false, then it's showing just sensors lighting up in the same, and then the red line is the direction, the true directions, I believe, the neutrinos. That's what we're trying to predict. So we're trying to predict that with these two values, which is the, what is this? Zenith and azimuth. Let's remember let's get a visualization of the zenith and azimuth. Yeah, so this is sort of explains what we're trying to predict. So we're trying to predict this zenith and is a viewing angle azimuth? I don't know. I love plotly charts. Would you resample the data or would you have to analyze it on entirety? I don't think we're gonna, well, I don't know. We're gonna have to find out. We're gonna have to find out. So here's an example, strangely, where when auxiliary equals false, you would think the line for this would go right through these dots, but in fact it doesn't. It doesn't go in that direction at all. So I don't know what's going on with this example. Here's with auxiliary equals true, so this should have all that noisy data with it too. So that gives us a little bit of an idea of the data. Let's go ahead and let's see what some of the scores are. So 1.274 is the best leaderboard public score. And it looks like this person, all they did was they ran a PCA, which is a principal component analysis. Hey, Zebra, thank you for subscribing. We're going to spin the wheel for you. Let's spin the wheel for the subscription. If you subscribe on Twitch, by the way, I'll spin this for you. And, oh, I need to type pizza 10 times. Let's go ahead here. There we go. I think I did it one extra time. That's for you. Thank you so much for subscribing. All right. So this is the best leaderboard, public leaderboard score right now. You can see they read in the training metadata, reading in batch 1, and then the number of pulses and the number of events. The index in this is the event ID, which is not necessarily a unique value. It's the event ID for each time variable and each sensor ID. Sensor geometry. So they take the sensor geometry. Sure. And understanding the data, I will explore event 67. Find the coordinates of each pulse from the sensor geometry data and mean normalizing. So this, it looks like he did do some normalizing by the average case event pulses. What is case event pulses? That is I don't like the way this is written. It's kind of hard to read. Why iloc this? Why not just query on this event? Uh, 10 times it used to be 100 times no. Am I crazy? I was hoping for the dad joke. Oh yeah, it used to be, yeah, inflation did hit. I'm not typing as much as I used to before. I used to type 100 times every time someone would subscribe. Then I realized I get nothing else done. So then they're calculating zenith target and the azimuth target. All right, so this gives us an idea of all the sensors that fired. I guess it doesn't give us the actual value of the sensors that are fired, but then we see the direction or the angle of the neutrinos. And let's see what the model, what actually PCA components does. PCA, that not components, fit in case event pulses. So we're gonna have to copy this. Let's download this code and let's play with it locally. Shall we? Okay, so I'm gonna actually go to my repositories folder. I'm gonna open up this IceCube Neutrinos Deep Ice, and I'm gonna open up VS Code here. I'm also gonna go here we go. So I made this GitHub repository with an input directory, which is empty. And we're going to have to, let's go ahead and move the file that I just downloaded, which is IceCube. Let's go into the notebooks folder and let's move this here. And then let's try to open it up in VS Code. There we go. Which environment do we want to be in? We want to be in... We want to be in a different kernel. We want to be in, let's do Kaggle 2023, shall we? And let's make sure this loads. Nothing named sklearn. So we're going to have to import that. Conda activate Kaggle 2023, pip install scikit-learn, of course, because it doesn't use its import value. What? You laugh when you saw it was on line 2K. Yeah, I've typed pizza a lot. I've typed pizza many times. Okay, so these imports work. Now it's gonna, let's change this input directory to .input. And let's make a directory. Here's the thing. The data was too large to put it in this directory. So I'm gonna have to go into input and make a directory, which I'll link ln.s, my mount. This is just mounting that data, Kaggle IceCube data into IceCube. All right, so I think this will do a soft link. So when I go into here, Kaggle IceCube data goes into here. Let's remove this. And let's go into ln. We're going to do this link again. Link this directory into here. Why would this... I'm gonna remove this. Do you have any present environment you have as the base of your environments you create, like basic environment that has NumPy? I just start from scratch and then I start installing stuff as I need it. All right. Let's remember how to do soft links, people. Symbolic link. ln-s, path the file to be linked. And I want to do a folder. So shouldn't this be ln-s? This directory should be right here. Kaggle IceCube data. This is what I need to do. I need to rename this. I'm going to move this Kaggle IceCube data into a new folder called IceCube Neutrinos. And then I'm going to remove this. And I'm going to link this mount ln-s mount Ramola my disk IceCube Neutrinos ice here. And now if I go here, yes, it'll link to the right directory. So all that's to say that now if I go into VS Code and I run this, it should work. But of course, I don't have PyArrow installed. This is like a brand new environment. So I'm kind of installing everything like you just asked. Is it classification or regression problem so that we can choose appropriate model or model? It is a regression problem. So because, but we actually have two different targets that we're trying to predict. We're trying to predict, remember this zenith, azimuth, these like two different angles. We're trying to predict both of them. And they could be any value that's not infinite in radians. So I guess 0 to 2 pi sounds about reasonable, right? And I believe some of these notebooks that did exploratory analysis of it showed us the distribution of these features. Yeah, so look at this. The zenith angle is generally between, like in this, I guess, between around 1.5, and the azimuth is, you know, consistently between anywhere between these values. Hi from Ukraine again. Finally catch you online. Thanks. Hey, Vasil, welcome back. I hope you're all safe and everything. Yeah, thanks for joining from Ukraine. That's awesome. Isn't Zenith just observer? Not quite sure. All right, so I've installed PyArrow. And now we're going to do this. Oops. Finally, it's reading something. There we go. Now that I've linked that directory properly, took me long enough. Let's see what's wrong with this reparquet with. No such file or directory. Kaggle. Oh yeah, this is ... input. All right, and then they have the sensor geometry, right? This just tells us how many sensors even are there. $5,160. And we can see this is sort of like the two-dimensional space. So if I rotate like this, like that, it does look like this 3D plotly plot kind of skews things. Because it's definitely wider than it is tall in here, in this view. But if we run this plotly version, is it not going to show us here? Yeah, it does show us here. So we can kind of see it in 3D. Now we're going to pull in the test data. I don't know why it has this twice. That must have been a typo. All right, so for the test set, they just give us 3 example values, events. But in reality, on the real test set, It's a lot more. So you need to make sure that your code can run on that larger test set when it's submitted. This test set, it's just for kind of testing out to make sure your code runs on a little bit of code. How do you feel about Plotly Dash versus other visualization when making dashboards? Well, I've been learning a lot about Dash, so I really do like it. All right, so what is this person doing here? Train batch 1, iLoc, train meta. So it's looking up in the training data. So for this case event, which is 3, why is case event 3? Okay, so case event 3 is actually 67. If I'm reading this right. Oh yeah, it says it really big here. It's number 67. So we can see that. I would just do this. I'm pretty sure case events pulses shape here. If we just did train batch 1 query event ID equals 67 dot shape 142 by 4. I'm pretty sure all this code right here is the same thing as just doing this. See how much, can you guys read this? See how much difference in code size this is? How can I change the font style in the markdown section? So font style, there's not much you can do, but you can add like a hash. This is a title. This is a subtitle. Then you can do like code snippet. This is normal text. You can do bullet point. And then you can do like a whole bunch of like that. So then when you render this, it'll actually show this as code, right? So it renders it different. Relian, thank you so much for our Leon. Yeah, thanks for hanging out. Thanks for the positive vibes. Okay, so what were we saying? We're saying the main thing here is that this could be made a lot easier by doing this. Unless there's something with the metadata. If there's some reason why we should use this first and last place. I don't think so, though. That's just the location in the batch. I don't see any reason why we should do it that way. Right, so let's just switch this out. All right, so then we take this case event pulses, which looks like this. This is the thing that I'm not sure about yet. Why are there different values for time? Auxiliary equals true, and then the charge value, the time value. What does this time value mean? Is this like time series? Are they not all coming in? Are all the values not coming in at once? We're going to find out in the data section. Time. The time of the pulse in nanoseconds in the current event time window. The absolute time of a pulse has no relevance. and only the relative time with respect to other pulses within an event of relevance. So it is sort of time series-ish data. Let's set our index to be time. And let's plot this. Right? All right, so this is in nanoseconds, but these are when all the pulses come in. So this is something interesting because, at least from what I've read, it doesn't look like people are visualizing these as time series. They're mainly just visualizing these as data points that are all for the same event. But in reality, they come in kind of a sequence. Zebra, why are you doing that with your head? Raid? We got a raid? Where's the raid? How many people raided? Someone raided me with 7 billion? How did I miss this? Let me go back. Overgrown Carrot 1. Thank you so much for raiding with the party of 7. Hope you're doing well tonight. We are just looking at a Kaggle competition here. What were you working on? XUTW is exaggerating a little bit on the number. All right, so let's also look at, so we have like a time component. We have a location of the sensor component, and then we also have this auxiliary value, and then we have the charge value. So let's group by auxiliary. We'll set the index first. And then we'll also add a legend. So this tells us the ones that have auxiliary true or false. I believe if auxiliary is true, then there might just be noise. Hacking Active Directory. I don't know if, did Overgrown Carrot say anything? I think he just, oh wait, no, he's there. We're doing cyber collabs, hacking Active Directory. That's awesome, Overgrown Carrot. Sounds like fun. Sounds like a lot of fun. So if you're just joining and you want to know the competition that we're looking at, here it is. Here's a link on Kaggle. You can check that out. Exodus says, I don't know anything about coding. What is that program he's typing in interface that's dark mode? This is VS Code with a Jupyter extension, and I'm writing Python code. So this runs Python code in a way that like us scientists can write code and then also write text next to it, but have it all kind of in the same, we call it notebooks. All right, so this mean normalizing that he's doing, it makes sense to reset this index. And then subtracting the average value. So let's just look at this. What's this case event pulses? Why does case event pulses here have an X, Y, and a Z value, but it didn't up here. Right? Case events pulses doesn't here. Then we plotted this. Title equals event 67 by, look at this Copilot trying to by time and auxiliary. It was actually right. Sensor geometry locates the, okay, so this is the same thing as a merge. This could be a merge, right? Basically what he's doing is he's taking event case, and it could be faster the way that it's written. Why isn't my autocomplete working? So we have this case event pulses, and then we also have the sensor geometry. And we want to take each sensor ID and get the X, Y, and Z location of it. So let's merge sensor geometry on sensor ID, set index time, group by auxiliary. No, we just want to merge. And then how should be left. And let's see if this let's just make this copied and then run the way that he did it, which was doing these index lookups. Let's see this shape, and then they're both this. No, okay, mine has one less value in the head or in the columns. Let's see where I'm missing it. Oh, that's because he also reset the index. Right, so if I do, but really you could drop those index. They're not really helpful. And then how do we do the mean averaging? Hey, not Tristan, welcome. Copilot on Jupyter. Yeah, it's VS Code in Jupyter Lab. Let's spin the wheel. Let's take a little break and spin the wheel, and let's check up on chat. What do you guys think about what we're doing so far? Oh, my gift discard subs aren't working, and prob sub isn't. Oh wait, drink water. This isn't water, but let's pretend like it is. Scream Kevin. I will eventually. I'm sure I will eventually. I'm sure the Kevin is coming. The Scream Kevin is coming. You guys just need to subscribe on Twitch. So this is one way to do it. Just like divide by the mean value. You can also from sklearn pre-processing import min max scaler. Like we could use like a legit scaler. Like standard scaler. KNN it seems. Excel learning by Excel expert. What's up in the chat? Yeah, so let's look at this. Let's look at this. I kind of want to look at this before normalizing. Oh, that's just averaging by the average X, Y, and Z values. I don't know if that's a good idea. Let's plot a kind equals histogram. This is breaking because I'm running it out of order. All right, case events pulses. Now if we do a histogram of this, of like the X value, we can see it's between negative 500 and 600. And if we do the histogram of, let's try all three. X, Y, and Z. And let's make more bins. And make an alpha so we can kind of see through it. Right? So the X, Y, and Z values kind of vary between negative 100 and this. So it's taking the mean value of all these. If we do the mean value, and that's just for this one case. But if we look at a lot of them, I bet it's going to average out to be a pretty smooth, normal distribution. I'm just guessing. I don't know for sure. All right, so the average value is actually negative for most of these, and that's what we're at. That's what we're subtracting out here in that line of code that they did. Let's delete this one. And this subtracting out the mean value. I don't know if that's the best way to do it, but let's actually do one of those histograms on all of this. Train batch 1. Which has sensor ID. Oh, that's the index. That's an index. Hey, what is this little gift thing? He gifted Z-Bars. Thank you for gifting subs. Let's go ahead and see if we can get Kevin. If we can scream Kevin as loud as we can. Will it land on Scream Kevin? There's a 10 chance out of all these summed. Do nothing. I'm sorry. I'm sorry. I appreciate you gifting a sub. That's very nice of you. You gifted it to Data Basics too. A good friend of the channel. So we have a lot more values if we look at this whole batch. So we're going to try this same plot with batch 1. Train batch 1. That's right. We need to, if we want to do that, we have to merge this entire data frame with the sensor geometry on the sensor. I love how it's doing all this stuff all together. So we're going to try this merge left. Now it has an X, Y, and Z. So we'll copy this. And then we don't actually have to merge it again. And this is something we should probably do in polars if we actually want to make it fast in the end. Hi there, Omak, what's up? Welcome. You can always watch the replay. Okay, so this is interesting to see. Like if we normalize by the average value of all of these, it's gonna maybe be better. I don't know, maybe worse, but it's gonna really change. The average value is gonna change depending on which event we use. The average X, Y, and Z value. I'm doing well, Rauk. How's it going? All right, so let's not go too crazy with this. And let's see what they're doing. They're taking out the zenith and azimuth values. and then making an array from negative 100 to 500 with this shape. Okay, that makes sense. And just drawing it here on the plot of all of the sensors that have fired. I wonder if a lot of these targets that fired are actually these early ones. Do you see that? Do you see how so blue is, I believe the color is blue if it's auxiliary, and if it's not auxiliary, it's blue. Otherwise, it is red. And in this, it's actually the opposite. It's orange if it's auxiliary, and it's blue if it's not. But look how we have these few values here at the beginning with the time that's less than, let's say, 15,000. And then we have ones that are greater than 15,000. I wonder if that's why we have some blue things over here that aren't by the main line. Let's see if this has something to do with the time period. So we're already filtering out here. These are like old school ways to filter. Like we could just do query. Auxiliary. And that'll do the same thing as this whole line of code, right? Query is our friend. And then we can do here, like not auxiliary. And it should make the same plot. But let's also query time. Let's make sure we have the right value here. Yeah, it's just called time. Time is greater than 15,000. So we're filtering down just to the right side of this plot for this event to see if it's anything different. If it's different, if we just split here, we can actually do 17,500. That might be a little bit better. This is just kind of a side tracking. A little bit of maybe a red herring here. No, but look at this. It kind of matches what, right? It kind of takes out some of the data that is not lining up with the line. So that's kind of interesting to think about. This might be a pattern where you want to like cluster by the time dimension and only consider when they're grouped closely together. Do they say anything about the possibility of two neutrinos at the same time? I don't know. We haven't read any papers yet. But that could be what's happening. Like this is an old one and this is the new one, but they're both considered event 67. So I don't know. Maybe it's going to be an iterative thing where we need to take out values that are not associated with it. All right, so he's making a principal component analysis with only one component, fitting it on all these X, Y, Z's. I don't understand how this works at all. So there are three components here. Okay, one for each X, Y, and Z. Then how does he take this X, Y, and Z and actually plot them. You make a vector data frame, which looks like this. Negative 227 to positive 227. I don't know, it works. Seems to work. And then he's scoring. And this is the angular distance function that we're given as the actual function for the scoring of this. Okay, I think I'm starting to understand. I think I'm starting to sort of understand how he's doing this. So get angles of the event data frame. If auxiliary is greater than 15, so that's one interesting thing we should look at is how many auxiliary events. Like if we group by an event ID, for some reason we dropped the index in the train batch 1, which has the event ID. So there's a lot to do with that. Hello, this is off topic, so answer whenever, but new year and new to code, started to learn, I would say a strong beginner, and having trouble understanding structure of programming in general and how different entities communicate. Any suggestions for how to get started with that? Just take a basic intro to programming course and just start from the beginning, or watch a lot of YouTube videos. Hey, that's another way to learn. But you just gotta stop asking. I don't mean to be mean when I say this, but I've been in this situation too, where I just ask a lot of questions, but instead of asking the questions, just go out there and try to watch a course on it, like on the very specific topics that are holding you back. Yeah, Free Code Camp is great. I did edX course on Intro to Programming when I first started. It was really helpful. So I'm starting to think maybe he did this. Did it this way is because it's faster. Like doing the iLoc stuff instead of query. And when you're running this on the test set, it needs to be pretty fast. All right, so let's get into the actual, if we were to build a deep learning model on this, what would we do? And I'm fairly certain that I saw these are people trying to figure out how many values or events are in the test set. Not all sensors used in one batch. Notebook through essential. What, do we try to predict an algorithm? What I'm trying to find here is someone linked to a paper Let's go to Google Scholar and let's look up deep learning for this. I know I read this paper earlier today. Neutrinos in deep ice. Let's see if this is not the one I saw before. But it does kind of give us an idea of what type of model we might want to start with. The one I was reading before actually used the time dimension also somehow. This is why you should. Oh, this is it. Deep learning reconstruction in Antares. Antares is currently the largest undersea neutrino telescope. So this is an undersea one. It's in the Mediterranean Sea. It's different than this one because it's not in ice. It consists of a 3D array of photosensors instrumenting about 10 MT of seawater to detect Cherenkov light induced by secondary particles. It sounds like a fairly similar thing, right? And when I was reading about this was their inputs. This was their structure. So even though their model says it was that way, they say in their data processing section that they used a 4-dimensional input of images containing the full spatial and temporal hit information. Therefore, the spatial binding chosen such that every floor is 1 pixel in the image, leading to a pixel grid of. So this is they call it an image, but it's kind of like just a tensor, a 3-dimensional tensor, 4 by 4 by 25. And then they use these time bins. So this is where that time dimension might come into it. If we're actually trying to, I hate that all this is highlighted. Where is it? If we're trying to sort of separate out this time dimension, we could feed it to the model in this way. But I'm not completely sure if this will work. And if we see how their model structure looks, I'm not quite sure why it's 25 by 161 by 3, because they just said here the dimensions were different than that. Or 4 by 4 by 25 by 100. But let's just ignore that for now. So this is just like a simple model structure that we could recreate. We could with PyTorch make this exact same model structure with all these exact same sizes. We could test it out. It's a completely different data set that they worked on, but we could try this application on this new data set and see if it works. This is their model, this DCN, and you could see how it's much cleaner in the way it was able to predict. So I don't know. Looks like it has some potential here. But let's actually see this. Let's see this. One thing I'm curious about is, is there only one sensor value per event? Let's make sure I am in latest Kaggle environment that I created. And let us look at batch 1. Let's group by the event. Let's group by the index. Let's reset the index. Then let's group by, I don't know if there's a better way to do that. Event ID. Can I group by just the event? And then let's do sensor ID and then n unique, the number of unique times. We might actually want to do like a value counts on that. So what we're trying to find out is all right, so this is telling us for each event how many unique sensors are there. For each event, how many unique sensor measurements? So most of them are pretty low. And if there are 4,000, I forget how many. So if we do the same thing and we do a value counts. Hi, Thomas. What's up? AVRG50. What's AVGR50? Okay, so this is telling us that each sensor ID actually could be multiple times, could occur multiple times. I did not expect that. Let's just see. And granted, we're only looking at a single batch here. Just in general, which sensor ID is the most common? 5038. Let's do this plot where that other people were doing where they're showing the sensor data. So I'm going to go in here, sensor geometry. Input the sensor geometry. Oh, it's a CSV. And then let's also import plotly express as px. So let us do our 3D plots. Let's also load an extension. Lab black. Put this all the way up here at the top. Come on, plot. Don't fail me now. Let's take the top 50. Yeah, so this is the top 50 sensors in our batch 1. So only the top 50 sensors in batch 1. And let's see if they're in a specific location. So if the sensor ID is in this, that'll be our second plot. Okay, so We made 2 plots actually. Let's just show this one. All right. So this is kind of interesting. I don't know. There, it's like the outermost. Okay, so we can color this by sensor ID, and we basically want to do the sensor geometry and merge this on our value counts, right? We could map this. We could actually map the sensor ID. And this will give us the batch 1 value counts for each sensor ID into the sensor geometry data frame. Batch 1 count. So that's like a new column in our sensor geometry. Why does it keep on? It's not defined. It's definitely defined. Pylance. Pylance, what are you talking about? So we're going to color by this on the count. Value color is not the name column in the data frame. Expected one of sensor ID. Oh, because I reread this in. Yeah. That's why. That's why it's complaining. Pylance was correct. I was wrong, okay? I was wrong. I can admit when I am wrong. All right, so looks like these bad boys here in the middle. Interesting shape for sure. These ones in the middle, and this is like the slowest way to zoom ever, tend to light up more commonly. And just in general, the lower ones tend to fire. Why is that? I don't know. I don't know. I did see someone posting that they saw examples where like all of the just one rod was firing, and someone said that was probably because of bad measurement or something. Let's see what they said. Yeah, this one. So Darian posted about this. Look, this auxiliary equals false. All the values are within this one rod, I guess I'm calling it. I don't know if that's correct term, but it looks a little odd. And Robert Hatch responded and said, neither pure noise nor you're overthinking. It's mainly an artifact of cost-effective placement of the sensors. For increasing X and Y density, you have to drill another hole in the ice. So very expensive. So increasing X and Y density. That means like the space. For Z density, they just need to add a sensor to an already existing giant string of sensors. So small Z movement is much easier for the sensors to detect than small X or small Y movement. Since it's 125 meters XY distance versus 17 meters of Z distance, triggering 3 to 4 vertically stacked, and that's far less distance apart than neighboring XY string. So I think what he's saying is, yeah, this Z axis isn't as deep as it appears. They're not actually this deep. And they're actually tightly packed in there. I don't know. Hello, Pro. What's up, Nguyen? Good morning, sir. What's up, Idris? Idris. They trigger. Yeah, so the height is tight, and if it triggers one, it triggers them all. If we go one, we go all. So we're trying to understand this. Now, here's the next step that I would probably take on this. Is we want to make a PyTorch data set. A data set, an input and target for each event. What's the size of the tensor that's coming in? And maybe just to start out, we don't care about this time dimension. What I was hoping is that each sensor ID would be only unique. But it doesn't appear that way. But let's just try to think. If we were going to make this... If we were going to make this into a tensor for each event, and then we also want the target value, which is train metadata. This, nope, we want this in train metadata.parquet. This is fun. You guys having fun? I'm having fun. I hope we're all having fun. So we want to take this each event, and this is our target. This first pulse index and last pulse index don't think really matters. What if we did this auxiliary equals false, group by one thing I noticed was in the other person's notebook, they had a different way that they fit their model if there wasn't a lot of auxiliary equals false values. So I guess we could group by the... Can you group by the index like this? Let's reset the index. Let's group by the event ID. And then let's do auxiliary. And then do a value counts of each. We could unstack this. What are people saying? Why do I use query over loc? Because I think it's easier to read. But I think it's a little slower. What is lab black? That is a auto. That just if you go to NB black, there might be a better way to do it in VS Code. But it's an extension that automatically will run the black formatter on all your code when you run a cell in Jupyter, which keeps it a lot easier to read. So I'll send you guys this link. All right. So this is just our auxiliary stats. I just want to see how it did that auto formatting. So much cleaner. So for the auxiliary stats, if we want to go by false, we could just do the whole thing. Plot kind hist bins 50. What? There's one where it's over 10,000? It's over 10,000? What is going on with this event? This event has so many values. Train batch 1. Oh, actually, if we go to train metadata and then we query, this is why I think it queries cleaner, event ID equals this event ID. I like how Colab tried to, I mean, not Colab, Copilot tried to say event ID equals a bunch of zeros. All right, so first pulse index and last pulse index. That's a big distance. Like we could subtract these to get the pulse index, and this will be our train pulse length. We're just exploring here. Trying to see how common it is to have pulses that are that long. It seems exceptionally long. We could actually make one of these plots for that to see if it looks any different. It might just have a whole mamma jamma of noise. Now, is this going crazy because of my memory consumption? Yes, my memory use is out of control. Let's restart this one. Restart this one. Still getting kind of out of control. We need to use polars here. Pulse length. So it's kind of hard to see. Kind of hard to see by just sorting. So we need to plot a histogram. And I guess we need like a lot of bins to show this. Maybe 100K bins. This is important to know because if our training data has like mostly short events, but then a couple of really long events, do we deal with those separately? Was about to say polars or CUDIF. Yeah, something else. This data might be too big for CUDIF for me because my GPUs don't have that much memory. For those tuning in late, what are we working on? We are Poopy Dan. Great name, by the way. We are looking at this Kaggle competition that came out last week from the IceCube Neuro Observatory, which is this like insane place on the South Pole, and I'm gonna send you the link here, that has all these sensors in the ground, and we're trying to develop a model based on these sensor data that can predict the direction of neutrinos. Neutrinos are particles that have no electrical charge. They're similar to electron, but nearly massless and electrically neutral. Neutrinos have fundamental properties that make them difficult to detect. So we're going to try to get around that difficulty and solve this problem. We're not going to solve it, but we're trying. So hopefully that catches you up. This has still been going on for a minute. I think I did too many bins. What do you guys think? Too many bins in this plot? Yeah. Now we can't see anything. It's hard to visualize data that's kind of spread out this much. Hey man, really appreciate the videos that you upload, especially the one about polars. Looking forward to more videos on polars. Hey, thanks. I'm glad you like polars. I do too. Yeah, look at this. There are just so many. We almost need a query where the pulse length is less than 100. Let's do less than 10,000. Over 9,000. Yeah, maybe I need to reduce this number of bins to something like 100. I'm guessing most of them are under 10,000, and then we can plot the ones above it as a different histogram. So I'm trying to think, do we make this kind of like a okay, so most are even under 1,000. Why is this taking so long? Shouldn't this be quick? Easy peasy lemon squeezy. Plug it into ChatGPT. Yes, ChatGPT will do everything for us now. Okay. If ChatGPT's up, is ChatGPT even up right now? Every time I've tried to use it recently, it's just not work. Let's see. So this is to, we need to detect the zenith and azimuth angle of a neutrino particle's direction given sensor values from the IceCube Neutrino Observatory. Write it in Python using PyTorch. Good luck, ChatGPT. Good luck. Let's see what it comes up with. How do I make these chats on the side go away? Oh my gosh. It's really confident. It's super overconfident in what it can do. I mean, this isn't wrong. This isn't wrong. It's using ReLU activation functions. And then this last linear layer is going to be of size 2, which will be the two things we're trying to predict. Mean square error loss. The loss actually should be the angular error. I wonder if someone's going to rewrite that in PyTorch. And then it's writing the training. This get new data makes things a lot easier too. New sensor values, model new that won't work, will it? It's worth noting that creating deep learning like this will require a large amount of labeled data and significant. Can you write the data set class to load this data from various Parquet files? So here's an example of dataset class that can load various Parquet files, pandas, and PyArrow. Yeah, this is right. It is kind of crazy how well this is doing it. Yeah, it needs to get the length, and then the get item method reads the parquet. This part's not going to be right. Yeah, this is just assuming one row per value. And it also doesn't have a transform method, so I don't know why we'd call this. But it does say this is just an example. And then it's showing us how to use a data loader. Man, it's doing our job for us. Stop it. Stop it, ChatGPT. All right. Most events have less than 200. So crap. This ChatGPT already did my job, so I feel kind of worthless. We're going to use that code that it created. Okay, so charge log 10. What the heck is that? Event ID equals 24. By the way, let's see if we do this, time it for this. How long does this take versus, oh geez, what did I just do? Yeah, how long does this take? 161 milliseconds versus loc train batch 1 event ID equals 24. This can be index. Because we're going to do this a lot in our data set, and I wonder if it's significantly faster not to use query. And if that's the case, we should avoid using it. Man, I'm not used to using Jupyter in... Yeah, so it is a lot faster. So it makes sense why in that notebook he wasn't using query. You could still do this. I mean, we could do... Let's see how the other notebook did it. See how he did it here, which was to take 1. So that's 67. We need to load in train metadata. Okay, we called it train meta before. Train meta. Don't want to rerun all that. And then we'll actually do Am I gonna ruin my stream? Did I ruin my stream? Am I still online? I do this every stream. I try to do too much on my computer and it doesn't like it. Are you all still there? Can you hear me? What are you guys saying? They still at our live stream format. Ask ChatGPT to do all the stuff, focus and talk to chat. Yeah. Hey, that could work. They said R is still heavily used in industry, so they want everyone to learn it. It's not that bad, but I love Python. Yeah. R is still around in some industries. I am still online. Okay, this is good. This is good. What do you guys think? Like, should we stop here? Could this be a good stopping point? We looked a lot at this. I think what's next is to try to figure out how to make this data loader. So let's actually look at what ChatGPT said. This is their suggested model. This is what we care about right now, is trying to get the neutrino data set working. So I think I need to install PyTorch actually in this Conda environment. Conda activate Kaggle 2023, pip install torch. That's about a gig. That's going to take a while to load. So this is a pretty common way. Let's just talk about PyTorch data sets. This is a pretty important part, especially when you want to first create it in a way that it's fast and efficient, because every time you train your model, it's essentially going to be using this dataset class to pull your data from disk, because in this situation, our dataset is too large to put into memory, as you can tell from me almost shutting down the whole stream earlier by trying to load all this data. So one thing we might want to do is actually figure out the format that we want our data set to be in, like the tensor value, the shape, and just pre-process all the training data set into that format. So and then we can like use gzipped numpy arrays. We have to figure out what way we're going to do that. I'm thinking that's why I was doing all this, looking into the number of unique sensors, because part of me is thinking that we have like a 3D tensor represented by, yeah, it's going to be hard. 3D tensor, kind of like an image of each slice of these sensors. And then we need to have another channel almost for the auxiliary true or false. Yeah, and that's about it. Let's see how this looks in 3D. Because if we just give it each sensor number, then if it's running a convolutional neural network, it's not going to be able to tell the distances, like the relationship of each value to each other. And this is sort of how it sounded like they did it in that paper we were looking into, but we need to research that a little bit more. So basically we've got to figure out how to pre-process all this and also save off that function, because we're going to have to use the exact same function on the test set. And then we're going to have to create this data set, this PyTorch data set, which pulls in those files, or maybe pulls in the Parquet files raw and then does all that formatting. And then gives us our target value. And then we can try to start training a model on it. And, ChatGPT has its model that it suggested to us. It's probably as simple as they get. bunch of linear layers. Or we could go into the some of the papers that we're looking into and see if maybe an architecture like this would work better. But essentially what all the model needs to be is it needs to be able to accept our input shape, and then it's going to have 2 outputs. These 2 angles. And then we got to train it. Make sense? Sound easy? No, it sounds like a full day of work. That's what it sounds like. One that we will have to get to another day. Or maybe someone will do the hard work for us and make a public notebook in the next few days. So it's a common tactic to wait a little bit later in the competitions to really get involved if stuff like that does come to light. Can you please explain why you downloaded the data instead of doing the whole thing on Kaggle? So just imagine the little bit of hiccups that we've been having here when I'm trying to run this locally and running out of memory and not sure if, some of the processes that I'm doing, like value counts or transforms of the data, takes up a lot more memory than you think. On the Kaggle notebooks, they have upgraded them, so they're pretty beefy, but the amount of times that it's going to break on the Kaggle notebooks when you're doing development, and then you have to start from scratch every time, can be a little bit frustrating. Also, locally, I do have Google Copilot, not Google Copilot, Copilot. So that's another reason to maybe, like I can say, yeah. See, Copilot can do similar things to ChatGPT, and this is like a super common way you can see to create your data loader. Oh wait, it might actually just be taking this example from above and trying to modify it. That might be it trying to outsmart us. I don't know. PyTorch is now installed. Yeah, this is not going to work. Basically, we actually want to give this the metadata data frame. And then the length is going to be the length of this metadata data frame. And it's kind of annoying that the events train metadata is not defined. So I haven't loaded it in up here. It's kind of annoying that the event IDs aren't unique. So basically we have to make a unique identifier for each. We're gonna have to do a train. We're gonna have to do a cross-validation split too. Man, there's a lot we have to think about. So I need to think about that offline. Did you guys have fun tonight? Did you guys have fun? I hope so. Do I have another PC I could make? PC setup for stream. You need a capture card. Yeah. That's how the real people do it. Are you working on the Neutrino competition? Yeah, we have been. Thanks for streaming. Thanks for watching. Thanks for hanging out, people. Let's go ahead and find some people on Twitch too. Can we expect a part 2? Hopefully. I need to see if I can have some time on my own to figure things out and probably be more helpful to people when I stream. All right, who should we raid here? Pot Chanty, what's up? Thanks for hanging out, people. Yeah, I'm gonna keep this up on YouTube. Oh, by the way, let me do all my shout outs here. Let's do all these here. So, if you go to YouTube, Rob Mullah, that is my YouTube. If you go to Twitter, Rob_Mullah, you'll get to me, hopefully. I think so. And if you go to my Discord, which is in our Twitch link, so !Discord, we'll give you a link to the Discord and you can join the fun and ask any questions you want there and we can talk it out. So hope to see you guys in any or all of those locations. Let's go ahead and let's rate. Oh, Chrissy Codes is doing TypeScript. Yeah, let's raid Chrissy Codes. It's been a while since I've done that. Nick Wan. Yeah, let's... Is Nick Wan... Oh, Nick Wan's on. Let's give Nick raid. So where is my rating thing? Here it is. Okay, we're gonna raid. And I will see you guys next time. So, oops, I picked the wrong one. Thanks everyone for hanging out. I'll see you next time. Stay cool. Stay in school. Bye. Bye, YouTube. See you guys.